our session by just an introduction to Arduino. Have you heard about this Arduino? Have you anyone? Okay, I think you can reply in chat box. Sometime I can see. Okay, Arduino board. I think it's the most familiar board presently available in nowadays. Even kids. My nephew, he is studying in 7th standard. He know how to use it. When I was in college, I first heard about this microcontroller board, everything. But nowadays, even kids know everything, all this stuff. So it's our duty as a teacher, as a trainer, it's our duty to improve our skill, knowledge, and update ourselves. So first of all, I thank you, Mr. Maheshar and team for giving me this opportunity to take a Arduino embedded sessions. Okay, first of all, what is it a microcontroller or a microcontroller board? If it's a microcontroller, you can type 1, or a microcontroller board, you can type 2. I mean, Arduino is a microcontroller board or a microcontroller. Okay, Samshay, it's a microcontroller, and okay, so I will explain all these basic things about Arduino. You don't need understand its internal architecture or its register address. You don't need to program Arduino board. That's the important things about Arduino. You just know the basic idea how it's work, what it means, and then you can program it. So I will explain. Let's start our first session, introduction to Arduino. So what's a microcontroller actually? A microcontroller means it's a collection of peripheral components. Simply we can say it's a collection of peripheral components. So we can also say it's a microcomputer, as any computer has internal RAM, CPU, IO interface, and so a microcontroller is a basically we can say it's a collection of peripherals. So what do you mean by a peripherals? So you can see my screen here. So it's let's assume it's a microcontroller. It have some inbuilt peripherals. I will draw a small box here. So just wait. You can see here it's a microcontroller, and I just add some inbuilt peripherals. Can you say some peripherals? So CPU, then RAM, IO ports, timer, so this is what is called some peripherals. So a microcontroller, it's a collection of all these peripherals. A CPU, it contains a small in-chip CPU, small RAM, small IO ports, and timer, user, and extra interrupt controller. There are a lot of control inside a microcontroller. So we can combinedly say it's a collection of some peripherals. So you can see that each this peripheral have some internal registers. So what do you mean by a register? What do you mean by a register? You heard that name already. So I explain everything in a simple way. Register mean by it's a memory address. You can store some data into that register. So each these peripheral have different types of registers, and if you want to program ICs like microcontroller like PIC, AVR, and everything, you need to know how to use this register. Register means it's a simply means it's a address, memory address. You can store value and you can read from there. That it means. Okay. So it's what we mean by a microcontroller. It's a collection of small peripherals. Peripherals means CPU, RAM, I/O ports, timer, user, everything. I think someone's audio's open. Okay, now it's okay. Now it's okay. So this is what is called a microcontroller. It's a collection of peripherals. So we can move back. So what's a microcontroller? It's a collection of peripheral devices, and we can say it's a small microcomputer, just like it contains CPU, RAM, I/O interface, and everything. So what's a Arduino? Arduino is a programmable hardware board. See, remember this point. Arduino is a hardware programmable board. See, Arduino is a it's a board. It's not a microcontroller. Arduino is a programmable hardware board which run 8-bit and 60 megahertz. Its frequency 16 megahertz microcontroller. It has some bootloader. Okay. So Arduino is not a microcontroller. It's a microcontroller board. Okay. An important thing is it's open source. It's free, open source. You can available all this related code and software and board everything, and its design also PCB design also available in open source, so you can directly program it. Then that's it. So Arduino is a hardware board, microcontroller hardware board, and it's a 8-bit data we are using, and 60 megahertz. 60 megahertz mean its clock frequency. Then why we are using Arduino? It's a microcontroller based prototyping kit. And if you have Arduino, you can do lot of projects. It's a simple microcontroller based prototyping kit. You can directly connect all these things. If it's a microcontroller, assume you can directly connect all your sensors into this board, and you can simply even students and hobbyists can easily program, and it's low cost. It's around, if you want to buy an Arduino board, it's almost cost 300 rupees for clone. The original Arduino board cost around 1500 to 1800. It's called a made in Italy version, but in our market in Amazon you can buy its clone. Cloning means normal uh, some people, I mean normal sellers, they make it and sell it. That's it, clone version. So you can buy it around 300 rupees, all these things, and many different board type. Arduino has different types of boards. Some Arduino Uno present, then Arduino Mega present. It's a different types of Arduino board version. Arduino Uno, Arduino Mega, then Arduino Mini. All these are different types of Arduino board. So depends on your requirement, you can buy different types of Arduino boards. And software API development environment, as I told you, it's provide a free software Arduino IDE. I shared the video how to download Arduino IDE, so please download it so that we can try Arduino IDE. Okay, then board layout and source. As I told you before, the board layout, I mean PC design and software is open source. This is why most people use Arduino, and this is why its community become very large. If you have any doubts, if you need any code related Arduino, you can directly just Google it. You can get that code, or someone somewhere asking the same problem you are facing, so you can easily find out how to solve that problem. That's why Arduino is popular. This session is mostly like a theory part, so just focus all these things because in upcoming session we need all these things, just like our clock frequency, then so let's move on next. Arduino board. It's a Arduino, some specifications. The Arduino is one of the most popular Arduinos available. As I told you, different versions of Arduino available in Arduino Uno, Arduino Mega, and Arduino Mini. But Uno is the most popular type available. Uno is the most popular type available, and we are using Arduino Uno here in our program. I mean virtual simulation. It based on Atmega 32.8 microcontroller. So the first question I asked, Arduino is a board, microcontroller board or a microcontroller. Arduino is a microcontroller board which contain Atmega 32.8 microcontroller. Atmega 32.8 microcontroller. So please remember this microcontroller name. It's contain Atmega 32.8 microcontroller. This microcontroller is provided by Atmel Corporations. Atmel. Okay, this is and I will some just okay, this is Arduino and it's contain Atmega 32.8 microcontroller. And you can see I will explain some specification about it. Contains 14 IO pins. 14 IO pins. IO means input output pins, and we can power Arduino using USB and power connector and 16 megahertz clock speed, 8-bit AVR RISC based microcontroller. Its architecture specification 8-bit AVR RISC based microcontroller. Actually, if you are really interested, you can look into its embedded programming. Arduino embedded programming, not Arduino programming. I will explain what the difference between these two, Arduino programming and Arduino embedded programming. Okay, then it has some internal external interrupts, USART serial interface. These all are communications available. Please note these things. It has USART and SPI I2C communications. So this is this is how our board look like. This is how our board look like. As I told you before, it contain 14. Just remember this number, 14 IO pins. 14 IO digital pin, not IO pins, IO digital pins. Okay, in these 40 pins, this board is already connected to, and the 13 pin is connected to inbuilt LED. It connected to inbuilt LED. Then the pin number 13 connected to inbuilt LED. Why I am specifying this pin is because once you start programming, you can see this is I think inbuilt LED. So if you want test your board is working or not, you can just upload this blink program and check whether this LED is working or not. This is how we test Arduino board is working or not. So this is 14 IO digital pins, and it also have analog pins. 6 analog pins. You can see name here, digital pins and 6 analog pins. So total it have 20 IO pins. 20 IO pins. In that 40 digital pins and 6 analog pins, and these are power pins. These are power pins. See, these are power pins. so digital pins, analog pins, IO pin, and this is our microcontroller we used. What its name? Atmega 32 Atmega 32 8P, 8 or 8P. 8P is a low power device, so it's not commonly called 8 Atmega 32 8X. So we are using Atmega 32 8P microcontroller. It's a bootloader. It's a bootloader. Bootloader used for that. If you have a USB connection, you want to communicate with this microcontroller. For that we using this bootloader. It load our X file, X code into this microcontroller. Okay, it's a bootloader. Then it's a microcontroller IC. It's our USB jack. So if you have a laptop, you can connect it through this your USB cable. You can connect our Arduino and you can just upload our programs. And this is power jacks. If you want to power externally, you can use this power port. So normally we are using a 7 to 9 volt, 7 to 12 volt for external power supply. External power supply. It's a voltage regulator, so it will regulate this voltage into 5 volt. Then it's a clock crystal we are using. Okay, and this is reset button. If you want reset your program, you can just click this button. It's a reset button here. So almost everything we explained. In that you remember this thing, the LED, I mean inbuilt LED connected to pin number 13. We have 14 digital pins and 6 analog pins, some power pins also. You can connect USB connector here, DC jack here. Okay, that's all about our development board. If you have any doubt regarding this board or what anything, you can ask me now. Okay.
Sir, someone has means Akshay Kadu has posed a question. What is the difference between
Clone.
clone and original board?
What additional work can carry on clone? Actually, the difference between clone board and original board is you can do all program in your clone board.
Okay.
See, some programs may not be working in our clone because I don't know this kind of program. I don't know exactly how to separate it, but some programs may not be working our clone. So if you
Okay.
are doing a project or industry related to something, make sure your
Yes.
board is okay. Okay, actually, if you want to say something.
No, sir. No, sir.
Okay. So
Okay.
that's a difference.
Okay.
Normally we can just do all program in same both boards. Normal
Hmm.
project, everything we can do in clone also, original board also. But sometime if you have higher processing program or higher size program, some communication program, IO port program, okay, it's okay, we can do in board. But if you go to the higher level, interrupt, timer, and some communication protocol, communication program, that time it may not be work. You don't know
Okay.
exactly what's the problem is, even because if you are doing a once we are doing a embedded project, you have two side. One is an embedded circuit side and a program side. The important thing is you have to fix one thing at first. See, normally what I'm do is I fix my hard software first. I mean not software, hardware first. I use a original Arduino board, so I can make sure that there is no problem happen that board. And once I set up my code perfectly, then I am fix my code and I change my Arduino board and test. Because in industry we can't use Arduino board. but we can use Atmega microcontroller. So once I remove this microcontroller and I start my PCB design circuits, that's what we do in real time. Okay, so if you are,
Right.
if your students also doing some projects, there are most of them are, I think, teachers, so you can say, don't go directly into PCB designing and everything. First you have to try a perfect board and just simulate and make sure it's working correctly, then only you have to move on the second level of, I mean, circuit designing. Most of the cases what happened is, I have seen some students, they know everything and first they are going to make their circuit and then after they are going to program it. But what happened is, if the circuit some errors we don't know, we think it's our code problem, our code is not working exactly, and we continuously changing the code without understanding what the real problem is. So if you are going some problem, I mean, if you are learning purpose, you can just use this clone board, but in project point of view, you can use the original board. It's made in Italy, you can buy it, it's thousands, around 1500 plus rupees.
Okay, sir. Thank you, sir.
Okay, actually, the same way, if you have any doubts, you can ask me. If I see someone will interrupt, okay, this is all about our development board. So if you want program a Arduino board, you don't need you don't need any knowledge about this microcontroller, how it's work. You only need this thing, this digital pins, analog pins. Okay, remember this thing, you only need these things, digital pins, analog pins. So you can see the pin 30 means it will connected to pin number 13. Okay, if you want to connect something and just an LED here, now I connected to pin number 7, so I just use this 7. So once I say turn on 7 means this will, it will have some high value here. So only you only need this pin number and how it's working, a rough idea about this board. Okay, so let's move on next PPT. So this is how it's look like our IC Atmega 32-8P. Atmega 32-8P. See, you can see here, I mean, it's a 28 pins, and you, here we have the Atmega 32-8 have 3 ports. It's an internal architecture. If you have confusion, you don't look into this. I'll just give a brief idea about what it's internal, how it's look like, everything. So Atmega, it have 3 port B, C, D. If you are looking at Atmega 32-8P, it contains 3 ports B, C, D. You can see here C port here, I mean C port, then B port, some port here also, some port here also, B, and also D port, some D port you can see here. Okay, then it contains 3 port, and each port contains 8 IO pins. Each port contains 8 IO pins. Okay, each port contains 8 IO pins. Then this pin, I mean, this pin have some multi-purpose, I mean, functionality, multiple functionality. Same time you can use as IO pins, input output pins, also some other multifunctional pins. Some pin we are using for communication, UART, SART. Some ports, I mean, some pins we are using for interrupts, timer. If you are using a pin, I mean a pin for your timer, you can use it as a IO pin. At a time you can use only one IO pin or a multifunctional pins. Okay, I will give you a rough idea about how these circuits, I mean our Arduino board look like. So this is our microcontroller, and you know what they did is they just create an Arduino board like this, and they internally connected this into different pins. Just assume, I will simply explain how they did it. and you don't need know all about this pin port register things. You just know about this 40 30 0 and just like some pin here A0 analog pins, we call it as A0 A1 up to A5. So you don't know anything about these things, only you need to know how this work and some basic C programming skill. By using all this you can program our Arduino board. So let's move on next. Our pinout, see, as I told you, the pinout description, some it's use, you can see here some pins, I mean digital pins. First I will explain all these digital pins: 0 1 2 3 4 5. This is digital pins, and A0 A1 A2 A3. Okay. And some of these pin use PWM pins. PWM means it will provide a varying signal. PWM means pulse width modulation. So if you want to create a sine wave, you can use these pins. All other pins only give you a digital output. The PWM pin, I mean digital output. The PWM pins, I mean pin 11 12 13, will provide you a analog output. So if I say the pin 30 only give you digital output, then pin 10 or 12 will both digital and analog output. Okay. So you can, if you want any kind of analog output, you have to look. If you connected, you have just look, I have a sensor, I need to provide it analog output. I need to provide it some analog output. If I connect it in this digital pins, it will not work. So by specification you only connect it into any one of the 6. How many PWM pins we have? We have 6 PWM pins. So if you want any kind of analog output mean it's a varying output. Okay. If you want any kind of analog output, you need to connect our device or our sensor into these PWM pins, and all these pins give digital output. Okay. Then the same time, if you want to connect any analog sensor as a input, here I explain output. If you want to connect any device as a analog input, you need to connect it into analog pins. So these analog pins will have inbuilt ADC, analog to digital converter. So it will convert our analog signal into digital signal. Just like an example, if we connect a potentiometer, I mean a port, just take this example. Port will give you what? 0 to 5 volt, varying voltage. Okay, it's a port. So I'm just going to connect it to my analog pin, any one of the analog pin. So input is 0 to 5 voltage, varying voltage. 0 to 5 varying voltage. If I just rotate the knob, it will change, but the microcontroller get it as a 0 to 1024. It's depend the your ADC. If it's a 10-bit ADC, you get if it's a 10-bit ADC, you get 0 to 1024 values as an input, and it's a 8-bit ADC, you get 0 to 256. I will show all these things in our simulation part. I mean tomorrow, next sessions, we will cover all these things: how to add a analog sensor as an input, how to read this value, how to send values, everything we will explain, and you can do it yourself. As I explain in video, by using this Proteus, you can simulate everything related to Arduino. There have some limitation, but most of the problem you can simulate by using Proteus. Okay, then it's a basic of Arduino, and I will explain almost everything related to this board. I will not go into this architecture section because it need more time and we don't have time, that much time. So I will give you a rough idea about how Arduino board look like and what all this component means: USB port, reset button, digital pins. Okay, is there anyone have any doubt? Okay. Okay, then we have power pins, a voltage regulator, power jack, everything, and Arduino pins. I will explain this later this session. Okay, this is some spec about Arduino. We are using Atmega. We are using Atmega 328P. Just add this thing also, P. And if someone asks, is there any difference between Atmega 328 and 8P? Yes, definitely there's difference between Atmega 8 and 8P. Okay, so you can add this 8P here, and operating voltage is 5 volt, then input voltage 7 to 12 volt. 7 to 12 voltage means we providing it using output source. I'm using my mouse, so sometime you can read this. It's using output source 7 to 12 voltage, and our inbuilt voltage regulator will convert it into our operating voltage and input voltage limits. You can limits, it's recommended, and you can supply up to 20 voltage, but always use this recommended voltage. Okay, then we explain 14 digital pins. It have 6 PWM pins. PWM pins will provide what? It's provide analog output. Analog output. Then we have analog pins. Analog pins, I mean analog input pins. We can also use this pin as output pins. So analog input pins and analog output pins, and current per IO IO pins. So you remember this thing. Pin current is 40 milliampere. 40 milliampere. Because why I am mention this point is, in future, I mean next or day after tomorrow, we are start to learn how to interface a DC motor. You just remember this thing. DC current per IO pins. It's a 40 milliampere. So that time I will ask what is current. So please remember this current per pin. Each pin have 40 milliampere current. It's provide. Okay. Then flash memory. Flash memory where we store our opcode or program. Opcode or program which is stored in flash memory. It provide a 32 KB where 2 KB used as bootloader. See what I mean by, as I told you before, we have system and we have microcontroller. So once microcontroller, so in between you have a module called the bootloader. So what this bootloader do is, it will communicate in between this microcontroller and this software, Arduino IDE. That's what bootloader do. Okay. Then SRAM, static RAM. EEPROM means what? EEPROM means electrically erasable programmable random only memory. EEPROM means electrically erasable program. This means, so you can have 1 KB, which means you can store data into this ROM. See, if you have some value, you need to store some value throughout your working of your microcontroller. Okay, this is my microcontroller, this is my sensor. Once I get a sensor value, I need to store it into permanently. See, each time you reset your microcontroller, it will start from the beginning. So if you want store a value data permanently, and each time restart you want to read that data, you have to store it into EEPROM. So it provide 1 KB EPROM and clock speed is 60 megahertz. Okay. So as I told you before, someone asked me what's the difference. If you are going to configure this EPROM and memory kind of things, sometimes there may be issue in clone versions of Arduino. So this is all basics about our Arduino. So we are now going to start the programming basics. Basic means I will explain only the things that you need to know. We can't explain programming in one session or one day or 1 week or 1 month. It's a very big. So I only explain the basic things we need to know or understand a program. So data type. What do you mean by a data type? Data type mean by if you want to store some values, you need to specify what it is. Just like I want to store a data in, so for storing I need some name. I'm declaring a name. This is data. It's my variable name, data, and I want to store it some value. So by defining this data type, we can say what kind of data it is stored. There are mainly three types: int, character, long, float. So we are using only these three things: character and integer and float. Okay. So I will explain how to the syntax. If you want to, okay, then programming. Okay, if you want to store a integer values, you have to declare this variable as int data. Okay, int data. So what happened is it will store only integer values. Okay, if you want to store some, I mean, float values, float value means decimal values. Just like integer value means 1 to 705 up to 100. Then float value means we have 0.7.5, then 1000.5. Just like if you get some if you have a sensor and it have a digital input, you can read by using integer data, and it have some analog input, you need to use float data. So how to declare a float data? Float data we can declare by using float variable name, data name. Okay, that's it. And we have one more thing here. It's what it is. It's character. So character is normally called as 1 byte integer. Character is 1 byte integer. I will explain this size. Character is a 1 byte integer. Integer have 4 byte. Then character have 1 byte. Float, long float have 4 or greater than 4. It's a number of size. 4 byte, 1, 4 greater than 4. It depends on compiler or processor. It's 32-bit processor or 64 bits. It depends changing. So normally we can say the difference between integer and character and float is their size, data size. I mean bit size. How much data they can store, it's depend upon or its size. Okay. Then I already explained what mean by integer and float. We can store integer value into integer data type data. We can store floating value into float. Okay, so what happened is if I store a integer value, I mean a float value into integer. See, I declare int x equal to 7.5. What happened it only store this 7, not this 0.5. So once you print this value x equal to 7, you get. Okay, that's happened. Now we are discussing this character type. You can declare a character variable using char, char. That's the syntax we used for. So int float char. We can declare a character data type. Okay, just you can use how to declare a character data type. So char name, variable name, and you can declare. So remember this, if you are mentioning character, I mean you have to express it in single inverted comma, and it's always 1 byte. Character is always 1 byte, so it's a character. Okay, you can put what's a character. It's a character means A to Z, it's a character, and 0 to 9 it's a character, and some hash, all special symbols are characters. Okay, you can write just like 12, because what happened, it's showing some error, because here 1 is a character, 2 is a character, so you can express just like this. It's an error. Character is always a 1 byte integer. Then I will explain one more thing. It's an important difference between all these things. Can anyone say what's the difference between this 0 and this 0, or this 9 and this 9? It's an important thing. What's the difference between this 0 and this 0? I'll just... Can anyone say? Yes. One is an integer, other is a character. Exactly. Okay, that's exact difference. See, this means it's an integer, and this means it's a character. So if you want to express a character, you need to express it this way. It's a character, and it's an integer, it's a character. Okay, so character means a 1 byte integer. The exact value, the real value of this means some, I think 65 or something. If you want look, you can see ASCII table. ASCII table, you get this value of this character. Okay, we will not we already have time, so I will not explain this thing in depth. We have to move on next section, next PPT. It's almost 45 minutes. So this is a basic data type, and next we are discussing the conditional statements. So conditional statement, it's really important, because you want to check or you want to put something, you need some conditions. This is how it look like. If and if condition, you have a condition, and then you have statement. So we have three type of if else if, and if else. Three types of if statements are provided. So I will give you a rough example. What happened? Rough example. See, I have a temperature sensor. I read this temperature value into this variable temp. I want to turn on one LED or one bulb when the temperature is high. So how do I program? First I need to develop that logic syntax. So my condition is if my temperature is greater than greater than room temperature, whatever it is, I just providing 30. Okay, then happen something, turn on LED. This is what happened. If my temperature is greater than 30, then turn on LED, turn on fan. That's my logic. So if condition is only executing if this condition is true. See, this inside condition is true, then only this if statement is executed, or else what happened, this else statement is executed. Okay, if you have one or two more condition, you can use this else if condition. So first it check this condition is true. If it's not true, it will not execute this statement. Then it will check whether the condition 2 is equal to true or not. Then it's not working, then it will not work, and finally it will execute this statement. Okay, so this is all about if condition. So now switch cases, it's a type of conditional. So I think we are not using this, so I will not explain. Later if we have time I will explain this, because okay. Then while loop, it's important things. While loop, we are using while loop. What happened is while loop used for a continuous executions. Normally our program is, what happened if your program start from here and it will end from here. So if you want to execute it continuously, you need to put in a while loop. You need to put in a while loop, and you have to use this condition. For infinite while loop, we are using while 1, while 1 for infinite loop. So we are using while loop, and also we are using for loop. For loop. It's once we are going to do some problem, I will explain it in detail. We are using for loop also. In for loop, the syntax is just like this. We have one initialization statement, one conditional statement, one execution statement, and increment statement. This for loop have 4 parts: initialization and condition checking, then executing the statements, after that increment that's variable. Okay, so for loop we used to for executing program in n times. If I want to blink my LED 10 times, I will use for loop. I can also use while loop, but it's better use for loop. Okay, then we are using LED blinking program and shifting LED using this for loop. You can set start and stop conditions, everything. Then this is our programming structure. See, Arduino have some programming structure. Normally each and every program have its own structure. So Arduino programming structure, it is, we have two syntax: void setup and void loop. In this void setup, we will explain only initial at once. Only this commands code we are used to work only at the time of initialization and execute only once. Okay, void setup, it contain commands or codes that execute only at once. That means void setup. Just like initialization, you need to turn on your LED, not LED, configuration ports and initial communication, you need to turn on. That's it. So we are using that kind of setup inside this setup code, and this void loop code we will use this, and I don't know, I mean we will use this continuous code. So if you want to execute this code, whatever code, I mean commands you give in this inside this void loop, it will execute continuously throughout the program. Once you reset that button, it will start from here. After that, once it will this code is execute one time, and then it will execute continuously. Okay, then this is the basic functions we are using: Arduino digital pin functions and analog pin functions. Okay, so remember this function name: pin mode, digital read, digital write. Okay, today I mean our third session, we will explain all this function, how to call, how to set, how to read. Okay, so pin mode means what? It will set either input or output. Okay, as I told you before, we have two types of pins. We can connect some input sensor and some output pins also. So how my Arduino understand which pin I connect which direction? So you can set here pin mode, pin number, direction. You know, I already explained. You only need to know the pin number. So I want to set this 13th pin as a output. I will set pin number 13 here. Then I will type output. Okay. So this way I can set pin mode, and digital read means I can read values from any pins. Digital read pin number. I will type here 12. If I provide any values, input values here, I can read using this digital read function and digital write function. If you want to set any high or low, set or clear any pin, you can use this function, digital write pin number. So I will give a explanation of how to write a LED blinking program, just giving logic. So once you start your program, just setting up, so you need to use this pin mode command in void setup, because at the time of initialization we need to set our direction. Okay, and this read or write you can put both in void setup or void loop. So how to write a pseudo code for LED blinking? First you need to digital write digital write 30 pin is 13 pin is, first I need to set high means 1, then I need to provide a delay for 1 second. After that I need to write digital write the same code with the 13 pin low. Okay, this is what happened. This is what the logic we used for LED blinking, and I will explain this code and how to connect, how to set up everything in my third section. Okay, so this is our basic rough structure. Arduino IDE, you can download it from the link I provided. Okay, you can directly download from their official site. It's open source, so there's no need. Arduino IDE. Then thank you. So this is all about our first session. It's a introductory session, and I can sure you I can promise that next session onwards we are doing more focusing on practical thing, because if you want to know this basic thing, then only you can understand that things. Okay, so this is our session. So please download and install this Proteus. So we will start our second session with the introduction to Proteus, how to use Proteus, how to add Proteus, then how to solve some, if you someone open Proteus, you can see that they are facing some library not found issue, how to solve it and everything. Okay, then this is all about first session. So if you have any doubts regarding our session topics, you can ask me now.
Any questions from participants? Thank you, Fasil sir. It was a very nice explanation from your side.